Alright, so this video I want to talk briefly about compression. Now, the big question becomes, why do we need compression, right? Why do we want to shrink our data down? And I think the obvious answer there is hard drive space, right? It's all about how much hard drive space do I need to store all my data. Alright, now some of you may be going, I got plenty of hard drive space, that's never going to be a worry. You know, you just bought a new laptop, you have a 1 terabyte hard drive in there for storage or whatever. And some of you may be going, yeah, I'm just about at the very end of my hard drive capabilities. If you're closer to more like me, then you might be going, yeah, maybe I do care about compression. If we look at my C drive, you guys can't see that. If we look at my C drive, you can see that I only got 22 gigs free there. Now, I do have a media drive that has 1 terabyte and a data drive that's 300 gigs. So I've got lots of hard drive space on my computer, but most of it is starting to get full. My media does have 147 gigs free, so still have plenty of hard drive space in that aspect. But compression is something that we all deal with. And truthfully, actually, the biggest reason we care about compression is not for storing data on our computers anymore. It's actually for transferring data from point A to point B. Whether that is from my computer on my desk I'm sitting at to my laptop that's, in the other room, or that's going from a data server in Canada to my computer here in Hagerstown. That is where we really care about compression. There are actually companies who will ship servers, or hard drives at least, from point A to point B because it will be faster to physically ship that hard drive than it is to actually upload the data to the internet over their internet connection and download it at another location, especially if cost is a big importance to you. It can cost you thousands of dollars a year, actually probably not thousands, millions of dollars a year if you're going to be transferring thousands of terabytes or petabytes of information from point A to point B. So that is truly why we care about compression. It has to do with transferring from point A to point B, not locally on our local machines. So now, many of you have probably heard of zip files. All right, some of you have heard of RAR, R-A-R files. And there are lots and lots of other types of file compression formats that you might hear about. Today, we're going to do a little example with just a few different options that we have on my local computer. So first, as you can see on my screen, I have the logo design file from the Hammer project group, Hammer investment group that we are working with. Just create a little compression folder. And if we look at this file, we can see that we have our size. The physical size of this is 19,385 bytes. Anyone know why the size on the disk in kilobytes is more? Let's just give a second. Think about that. Look it up if you want to. And moving on. So the reason that the size in kilobytes is smaller than in bytes is because 1 byte, or 1 kilobyte is 1,023 bytes. So that is why when we just give the straight up bytes versus it in kilobytes, we have a bigger discrepancy there, I will say. So, but anyway, let's look at the bytes because I like that number better. It's bigger, gives you more variation, just more information. So 19,385 bytes. We also have a size on disk here of 20,480. All right. And the reason we have that differential there is because of hard drives. All right. Trying to locate things on hard drives. I've posted a video and a website on our D2O website that kind of explains why we're talking about those bytes and whatnot there. And the real answer comes down to is sectors. All right. We break our hard drive into multiple sectors, which is just a logical group of bytes. So that way it is easier for the computer to manage where information is stored and located in a much quicker time frame. And more often than not, you're going to have files that are of the larger capacity. All right. Now let's just, for fun here, let's go ahead and just make a text document called text. Notice it says 0 kilobytes. Let's go ahead and look at the properties. We actually have 0 bytes. Let me go ahead and just put 1 letter in here. All right, I have 1 letter on there. Notice that is 19,000 bytes because it's more than just 1 letter. All right, but our size is still 2480. All right. So each sector is actually 4,000 and I believe it's 96 bytes. We'll come back to that when I have that number in a different window. But anyway, So each sector is how we really store information, and we do it for the point of processing and keeping our hard drives a bit more organized and being able to logically locate stuff without having to memorize every single byte on the hard drive. So those types of things. But anyway, so first thing we have is here, and notice it says it's roughly 19 kilobytes. We'll come back to the specific details overall later. But anyway, so if I right click on this, and we're going to do the send to, and we're going to do a compressed zip folder. All right, we're just going to leave it as. Now all of a sudden we're down to 12 kilobytes, and if we look at the properties there, we can notice that we're actually at 12.145 bytes and 12,288 bytes for our size on disk. So we have come down a whole sector overall compared to the old one. Another type of compression that we have, at least that I have installed on my computer, is RARs, or WinRAR. So if I do an add to archive here, I can see I have a RAR archive type. I could also do a zip here if I wanted to, but I'm going to go with a RAR just so we can see the differences. And again, roughly the same size. This one is 12074, and this one was, I believe it's 12145. All right, so slightly more compressed with the RAR than it is compared to the zip. Different compression algorithm and formula and things like that. So, you know, to each their own. They always have their benefit to use one over another, but is that benefit worth buying extra software to you is another question that's worth looking into. And the last compression that I want to talk about in this video is the Ntfs built-in compression that Windows can use. So if we actually right-click on a file and we do Properties, and then under the attributes, we do ahead and go Advanced, you can see down here we have a compressed contents to save disk space. So we're going to go ahead and check that. We're going to go hit OK. We'll apply it. And the part that really intrigues me here is the physical size is 19,385 bytes, but our size on disk is actually less. It is physically smaller on our hard drive than the file actually is in real life, which is really interesting, right? Always, no matter all the different file types we have, it's always been bigger, the size on disk. It's always been actually physically larger on the hard drive because of the whole sector thing. This time, however, it's actually smaller, and that's because we are compressing that on our hard drive. This type of compression is actually uncompressed on the fly. So it's not even like a zip file where you open it up and you're in the zip. You can tell because it's extract the top. And I can still double click on this and it opens the file just fine. It does a quick uncompress and then shows you the file for you. This type of compression that we're using here, it never goes into that zip phase. All right. You notice it does say, oh, we're in the compression folder. Anyway, I can double click on it. It opens just fine. It uncompresses without any issues. So, but it's really quite interesting seeing that file is compressed on the hard drive, but yet in full size it is, or in real life, it's actually larger, which is really quite amusing, interesting. Now, so we're going to move back. We're going to take a step back. We're just going to look at those file sizes. And here I have some of those file sizes listed. So here you can see our original design was 19,385 bytes. On disk, we're using 20,480. When we just did that compression with the Ntfs based one, which is built into Windows, you can compress entire folders that way. Size on disk is still the exact same, but notice the file size is exact same, but our on disk has shrunk down one category, one tier of that sector. And those are 4,096 bytes. I misspoke earlier. 4,096 bytes is one sector size on modern computers. Now, modern computers, this is as of 2020. Future releases, they might make that sector size bigger. They might go back smaller. It really depends. And some versions of Windows, the sector size varies based on how big the partition is of the drive you're using. So if you're only using a 4 gigabyte partition, it might be only 1,128, 124 for your sector size. Whereas on my computer, I'm on a 256 gig SSD or 250, somewhere in there. We're using the 4,096. Now, if we go down the step, you'll notice that our size on disk physically went smaller. So now we're 12,074 with our on disk being 12,288. So our physical size on the disk is actually decreased and our physical size in real life has decreased. But now again, we are compressed. We are needing extra software to actually open this file up compared to being built into Windows. Yes, the WinZip or the Windows dealing with zip files is built into Windows as well, but that is still an extra step. That is still something that you will notice actually happening compared to this actual just compressing it. So really quite interesting to me seeing that difference of the on disk versus the file size is really quite interesting. So, as I said, compression. Our main purpose is for transferring files. All right, some people will say it's for dealing with or for archiving files and things like that. There are better ways to archive files than just compressing them. And you do have to be kind of careful because people will do, well, I'm going to take this folder and compress it, and they do that with 10 different folders, and then they compress those 10 folders into one file again. And you will get to a point where if you've compressed something too many times that it may not uncompress properly. All right. So you may actually have lost that data. There is something called lossless compression, and there's those types of things. So like going from a WAV audio file to an MP3 file, you're going to lose a little bit. I believe it's normally the very highs and the very lows that you're going to lose a little bit of data on. But for the average ear, you don't mostly hear that. So that would be, you're losing some data, but it's not data that is absolutely necessary to have. Where if you are compressing a Word document and you lose stuff and you're losing every other word or something like that, that's data that you actually need. All right, and all the compression algorithms, they all work slightly differently. Some will go through your document, and it's kind of interesting when you compress pictures versus Word files versus audio files, those types of things, to see the difference in how it actually compresses. And you will get to see somewhat of that difference in your homework assignment dealing with this. So I believe it would be case study 25A. So just want to talk a little bit about compression. This column over here on the right is how many sectors of hard drive disk that we're taking up. So that's, again, sector is 4,096. So you can see 3 sectors would be 12,288. 4 would be 16,384. 5 would be 2,480. And as the file size is just getting bigger and bigger and bigger, we keep dealing with that. And here you can see I've just gone through and searched for all of my data of smaller files. So if we look at a 10 kilobyte one, that size on disk, you can see we are down at the 12,288 mark. And actually, let's see if we can go even lower. Let's just make this 1 kilobyte. Let's look at this 6 kilobyte one. So here you can see, there we go. We're really small. We're only at two sectors of 8,192. And then as we increase, if we go find a 7 kilobyte file, let's see, we're still at 8,192. We go to an 8 kilobyte file, which I do have a few of them in here. We can go ahead and look at those. So we're getting closer, and then once we go up to that 9 kilobyte range, you'll see we've jumped to that next sector of 12,288. And then again, we got to get up closer to the 15 mark. 12,288. So again, let's look at a 12 kilobyte file. Yep, still at it. Let's look at the very high end of my 12 just for good fun. So we're just barely below. We're only 100 kilobytes below. I don't know what this one is. Still like just barely 100 below. And then once we go up to that 13, we jump a whole sector size. So just kind of interesting to see how those file sizes fit into their different sections. So anyway, just wanted to give you a quick talk on compression and our differences from a zip to a RAR to just using the Ntfs compression built right into Windows to just a bare file. So if you have any questions, feel free to let me know.